All right, each day this week we are going to review a different concept from the second semester. And today we're going to start with trigonometry. So I am going to go through each of these different types of examples that we did in trigonometry, and then you have an opportunity to practice some more from a practice packet that we have for the semester. And I am going to collect that packet the day of the final for a homework grade. All right, let's go ahead and get started. Very first question is to determine whether or not a triangle exists. Well, later on this lesson, I'm going to teach you to determine whether a triangle is right, acute, obtuse. But in order for a triangle to even exist, reminder that A plus B has to be greater than C. C is the biggest number. Okay, so in our case, I'm going to check to see that 9 plus 12 is greater than 19. Well, 9 plus 12 is 21, which is greater than 19. So since this is a true statement, yes, a triangle exists. Over here, 11 plus 13 is not greater than 28. Okay, that doesn't work. All right, so therefore no triangle exists. So big thing is just remember C always has to be the biggest number, and the sum of the two smaller ones have to be greater than that third side. All right, let's go down to example 3. One of the big things that we talked about was solving for a third side in a right triangle. And reminder, the hypotenuse is always the one that is opposite the right angle. We are going to use the Pythagorean theorem here. So we are going to say that 6 squared plus 8 squared is equal to x squared. We're going to do our math. 36 plus 64 is equal to x squared. 100 is equal to x squared. Take the square root of both sides, and x is going to equal 10. So using the Pythagorean theorem, we're able to figure out the third side of a triangle. Reminder, a squared plus b squared equals c squared. C has to be the hypotenuse, and in our case, x is c. All right, number 4, still using the idea of the Pythagorean theorem. Our goal is to solve for x. This time, x is not the hypotenuse. Our hypotenuse is actually 16. Okay, and since the hypotenuse always has to be the longer side, the longest side, therefore it can't be 20, because 20 would be bigger than 16. It can't be 16 and a half, and it can't be 240. So it looks like it's going to be D. But we could do the math and show that x squared plus 4 squared is equal to 16 squared. X squared plus 16 equals 256. If you subtract 16 from both sides, you get x squared is equal to 240. Take the square root of both sides, and x is going to equal 15.5. Okay, but just using a little bit of logical reasoning, okay, understanding the hypotenuse has to be the longest, therefore x is 15.5 as well. All right, down here, big idea, okay? We've talked about the idea of right, acute, and obtuse. All right, so reminders, and you might want to write this down. For right, okay, we need a squared plus b squared to equal c squared. For acute, we need a squared plus b squared to be greater than c squared. And for obtuse, we need a squared plus b squared to be less than c squared. Big thing that I always talked about was just remember one of them, and then the other is the opposite. All right, so 10 has to be c. Over here, 13 has to be c. All right, big thing is remember that the biggest side always has to be your c. So I'm going to do 6 squared plus 8 squared, and I don't know what to fill in here, so I'm just going to leave it blank, is 10 squared. I got 36, 64, and 100. Well, 36 plus 64 is 100, so 100 equals 100, telling me that these three sides form a right triangle. Okay, over here, 9 squared plus 11 squared, and then I don't know what to put here, so I'm going to say 13 squared. So 81 plus 121, and 13 squared is 169, 81 and 121 adds up to be 202, which is greater than 169. And since a squared plus b squared is greater than c squared, that means that this must be an acute triangle. All right, this would be something I might want to write down and, just put somewhere just so you have it to, study from later. All right, going on, we talked about the idea of SOHCAHTOA. So SOHCAHTOA. We need to remember that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. The very first thing we are going to do is label our sides. We're going to label our sides based upon where R is. Okay, so to start, your hypotenuse is 82. Notice 82 is the biggest number. It's opposite of the right angle. 18 over here is opposite of R, because I can draw an arrow straight across to it, and therefore 80 must be the adjacent. So if I want sine of R, and they just want me to express it as a fraction, they simply just want me to put the opposite over the hypotenuse. So I'm going to go 18 over 82. Don't worry about doing it as a decimal. Cosine of R would be the adjacent over the hypotenuse, so I'm going to just go 80 over 82. And then tangent of R is opposite over adjacent, so therefore it is 18 over 80. And I'm done. All right, that's practice to get us used to setting it up so that we can solve. So on number 8, reminder, I gave you like steps on how to do this. Step number 1 is to label your sides based upon where this angle is. Well, it looks like 22 is opposite of 61, and x is the adjacent. This blank side over here would be the hypotenuse. But I'm not going to label it, and the reason I'm not going to label it is so I don't confuse myself. Because now that I see I have an O and an A, I think, oh, tangent. Tangent uses the opposite and the adjacent. So now I write an equation. Tangent of 61 is equal to the opposite, 22, over the adjacent x. We talked about putting 1 underneath our trig function and then cross multiplying. 1 times 22 is 22. Cross multiply here, and I get x tan 61. To get my x by itself, since I'm multiplying by tan 61, I'm going to divide by tan 61 to cancel that out, and I'm going to divide by tan 61. I'm going to type this into my calculator, 22 divided by tan 61, and when I do that, I get x is equal to a 12.19, and we could round that to 12.2. Okay? So reminders. Number 1, label your sides. Based upon how your sides are labeled, that's how you determine what trig function to use. Once you create your trig function, remember cross multiply and solve. All right, last concept here is when we do our inverses. Inverses are always used to figure out an angle measure. Since they want us to solve for angle A, our process is very similar to what we just did. First thing I'm going to do is I'm going to label sides. 15 would be the opposite. 20 would be the adjacent. This blank side over here would be the hypotenuse, but I'm not going to label it. Since I'm using tangent, remember it's always tangent of the angle. Well, I'm trying to find angle A, okay, and that is equal to the opposite 15 over the adjacent 20. Anytime we want to get the A by itself, remember we're going to move the tan to the other side, and when we do that, we're going to use that tan to the -1 on our calculator, which means you're going to have to hit second tan. Okay, tan -1 of 15 divided by 20. Type all of that into your calculator. And when you type that in, you should get A is equal to roughly 36.8. And we said to just always round to the nearest degree, so we're going to change that to 37 degrees. And the reason is that way our angles easily add up to 180 degrees and not like 180.1, okay? So always round to the nearest degree. All right, that's a quick review of trigonometry. Now I'm asking for you to practice the trig questions that are in the semester review packet that, like I said, I am going to collect the day of the finals.